I still cannot believe these results even after proving. Their proofs are not that hard, like we can easily get the results. But the fact that if we are summing from n equals to 2 to infinity of Riemann zeta of n minus 1, so basically we are summing Riemann zeta of 2 minus 1 and then Riemann zeta of 3 minus 1, Riemann zeta of 4 minus 1. Yeah, and these values are pi square by 6, pi to the power 4 by 90, and this is a new constant, upper is constant, and like values are like so ridiculous. But in over here we have minus 1, minus 1, minus 1 going from 2 to infinity. Yeah, and these like ridiculous values nicely sum up to just 1, and that seems pretty awesome. Yeah, and now in this video let us prove this. We will begin with the first one itself because this one is kind of easier. Yeah, and then these two are just the same. We will do all of them though. Let's begin. So we have sum from n equals to 2 to infinity Riemann zeta of n minus 1. Yeah. Now we have sum from n equals 2 to infinity. We can break the Riemann zeta of n as sum from, let's say, m equals to 1 to infinity and then 1 by m to the power n. Yeah, basically Riemann zeta of s, if it was s, that is just 1 by 1 to the power s plus 1 by 2 to the power s plus 1 by 3 to the power s, and that goes on. Yeah, so that's why now we have this and minus 1. Okay, now what can we do? Now notice that like this one can be broken down as sum from n equals to infinity. Now this can be broken as 8 1, this is just 1 to the power n, which is 1, plus sum from n equals to 2 to infinity 1 by m to the power n and then minus 1. Now plus 1 and minus 1 cancels out. Yeah, and what we have is sum from n equals to 2 to infinity, sum from m equals to 2 to infinity 1 by m to the power n. Yeah, now since this is converging we can exchange the sum. Yeah, basically we can exchange these sums, take the first one back and the second one in front. Yeah, because this will make our summation easier. Yeah, now our summation will not be that hard because now it's just a geometric series. Yeah, because now our first term will be 1 by m square. Yeah, and our ratio will just be 1 by m, and so we can calculate the sum of that geometric series, and it's going to infinity, and also modulus of 1 by m is less than 1 cos m is greater than equals to 2. So we have a by 1 minus r. Yeah, and so we have sum from m equals to 2 to infinity, and that will be 1 by m times m minus 1. Is that? M goes over here, and 1 by m minus 1. Yeah. Now this can be written as a telescoping sum. So I'm going from n equals to 2 to infinity 1 by m minus 1 minus 1 by m, because if you add these two we have m minus m plus 1, so that's the same. And this can be found out by cover up rule. Yeah, but it's pretty obvious, like these things are pretty obvious though. Now if we try to evaluate this, we get first of all m equals to 2, so 1 by 1 minus 1 by 2. Now m equals to 3 plus 1 by 2 minus 1 by 3, m equals to 4 plus 1 by 3 minus 1 by 4, and it goes on, goes on, goes on, goes on. So basically cancellations, 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 and this is the only thing that remains, which is 1. So we can see that this sum is neatly just 1. Yeah, so now we have found the first sum. Let's go to second and third one. Those are pretty similar. Oh, and I think I forgot to write n equals to 1 to infinity over here. Okay, that doesn't matter for now. Okay, so sum from n equals to 1 to infinity, Riemann zeta of 2n minus 1. Similar procedures, sum from n equals to 1 to infinity. This is okay, Riemann zeta of 2n. So sum from m equals to 1 to infinity, 1 by m to the power 2n, yeah, minus 1. Now similar, like first term will cancel out with 1. So we have sum from n equals to 1 to infinity, sum from m equals to 2 to infinity, and then we have 1 by m to the power 2n. Again, we have similar procedures. Okay, yeah. Now we can interchange them. So we have sum from m equals to 2 to infinity, sum from n equals to 1 to infinity of 1 by m to the power 2n. Now this is a metric series with first term 1 by m square and the ratio also 1 by m square. Yeah. So we have sum from m equals to 2 to infinity. Now this is just 1 by m square by 1 minus 1 by m square. Yeah, a by 1 minus r. So this will evaluate, so this will evaluate to sum from m equals to 2 to infinity. Now this will just be 1 by m square minus 1. Yeah, is that our first term is m square, and then okay, and then the rest is also m square. It's fine. Now this is 1 by m minus 1, m plus 1, and going from m equals to 2 to infinity. Now we can again use telescoping sum. So basically if we introduce 1 by 2 over here, we can write this as m plus 1 minus m minus 1, yeah, by m minus 1, m plus 1. Now this is just 1 by 2, sum from m equals to 2 to infinity, and this is 1 by m minus 1 minus 1 by m plus 1. Okay, now just evaluate this telescoping sum and we get the answer. So basically at m equals to 2, we have 1 by 1 minus 1 by 3, and then we have m equals to 3, 1 by 2 minus 1 by 4, and then we have 1 by 3 minus 1 by 5, and then 1 by 4 minus 1 by 6, and then 1 by 5 minus 1 by 7, and this goes on. Now let's see the cancellations. This cancels out, yeah, and this thing will also cancel out over here because we have 1 by 6 over here, and this is also cancel out somewhere here around here. This cancels out, this cancels out, so the remaining terms are 1 by 2, 1 plus 1 by 2. So this is 1 by 2 into 3 by 2, that is 3 by 4. So 3 by 4 is the answer. Yeah. Okay, so basically now it's obvious that because this one, because now over here we have sum of 2n minus 1 from sum going to n equals to 1 to infinity, because this is 3 by 4, yeah, and we have that from n equals to 2 to infinity, this is just 1, yeah. Now this includes all the terms from n equals to 2, 3, 4, 5, 6, 7, 8, 9, 10, all. But this includes 2, 4, 6, 8, 10, 12, in those terms. Now for the odd term, obviously for the odd terms now the result should be for sum of 2n plus 1 minus 1, the result should be total minus for the even, so 1 minus 3 by 4, that's just 1 by 4. Yeah, and if you would like to confirm from other way, you can also make a similar approach as here and here. So you can also make the similar approach. First of all, change Riemann zeta to a sum, and then cancel the first term and interchange, use geometric series. If you do the similar procedures, you will also get 1 by 4 from that way as well. Or you can also use the fact that the first sum is the sum of second and third, and first term is just 1, second is 3 by 4, so third should be 1 by 4. So that was it. Hope you enjoyed the video. Like, hope you also got some interesting results that's somehow unbelievable. Hope you enjoyed the video. Look forward to seeing you in upcoming videos too.